Now we're going to look at the social context of the Industrial Revolution and Great Britain. We see industrialization happening in Great Britain in particular, and we're going to look at three reasons why this is happening. One is we have Queen Elizabeth who outlaws wood cutting. The forests in Great Britain are getting diluted, so the Queen outlawed wood cutting. Wood was used for fuel and construction, and they needed to control this. They looked underground and found coal. Now they found a new material needed for building and for fuel. Next, British democracy encourages free enterprise. Britain wasn't really run from London. The transportation system in Great Britain was pretty bad. There was tendency for local freedom in what was done. London was far from the West Midlands, and so they left them alone. And that kind of democracy encouraged free enterprise. All didn't come from London. And finally, island isolation provides political stability. Great Britain avoided wars on continental Europe, and they hadn't been invaded for about 700 years. Therefore, there was a sense of security. So very briefly, that is the social context surrounding Great Britain and what allowed structural art to flourish, in particular in Great Britain at that time. And the most famous structural engineer of this era was Thomas Telford, born 1757, died 1834. Telford was brought up in poverty. He worked since he was 8 years old and began his career as a stonemason. In 1782, at 25 years old, he left for London, where he worked as a draftsman in an architect's office. And in 1787, he worked as a county surveyor. He designed his first bridge, a 3-stone arch span, completed in 1792, and at that time he began to become recognized. In 1795, there was a big flood over the Severn River, where the iron bridge is. This flood took out all bridges except for the iron bridge. The stone bridges essentially acted as dams, the water pushed them over, and the wood bridges were lifted up by the water. The iron bridge was light enough so that water could go through it, and it was anchored down. When Telford saw this, he was impressed, and he turned his attention from masonry to iron. There was an opportunity in Great Britain to build bridges and canals because this was the infrastructure for the Industrial Revolution. The Bilvaas Bridge was the first bridge he designed of iron. It wasn't a great work of structural art because it has 2 arches, and you don't know by looking at it which arch is carrying the load. So this is what we call an ambiguous form, meaning there is ambiguity in the way that we see the bridge because we don't understand how the loads are being carried. It was copied after wood arches, so it's essentially half engineered, half craftsman design, and it's also built over the Severn River. If we look at Thomas Telford's early works, we're going to study 3 of them in this lecture. One is the Bilvaas Bridge, a 130-foot arch that I just spoke about, completed in 1795. Next, we're going to look at the Pont Casilta Aqueduct, which has short span arches completed in 1805. And finally, the Bonar, at a 150-foot arch completed in 1810. To be clear, Telford wasn't the only one building iron bridges at this time, nor were they the longest spanning ones. Telford's only bridge design rival, John Rennie, designed iron bridges on the order of 200 feet, for example. But as David Billington writes in The Tower and the Bridge, quote, "What set Telford apart is his distinct personal style. His iron arches are more visually attractive, and they are also technically superior. A compilation of cast iron bridges built between 1779 and 1871 lists the bridges in order of their technical quality. Of the top 9 listed, 8 are Telford's. Of those 8, 5 are still standing today." End quote. One of the bridges that no longer stands is the Bonar Bridge. It was taken down after 90 years because it was hard to maintain, not because of a defect. It's a cast iron bridge spanning 150 feet. His design criteria for this bridge were essentially efficiency, economy, and elegance. He didn't use those words exactly, but he did use these words to describe the design criteria for Bonar Bridge. Quote, "To improve the principles of constructing iron bridges, also their external appearance, and to save a very considerable portion of iron and consequently weight." So if we take apart that sentence, we see he writes, "to save a very considerable portion of iron and consequently weight." There he's talking about efficiency. When he speaks of to improve the principles of constructing iron bridges, there he is talking about economy, because economy is strongly linked to construction. And finally, when he speaks about the external appearance, he is talking about elegance. So in essence, the design criteria for the Bonar Bridge encompasses efficiency, economy, and elegance. The Pont Casilta Aqueduct carries the Llangollen Canal over the valley of the River Dee in northeast Wales. Completed in 1805, it's the longest and highest aqueduct in Britain. Viaducts were important to connect cities in Great Britain. The Industrial Revolution required transportation. A pre-Industrial Revolution map of 1760 shows that there's not many rivers connecting the major cities. For example, Birmingham and Manchester were great industrial cities, but they were isolated. You couldn't go north or south via water, for example. Therefore, there's lots of canal building to connect these rivers. And a map just 30 years later in 1790 shows tremendous progress in connecting these cities via waterways. The Barton Aqueduct of 1760 is an example of what was done prior to the Industrial Revolution. Everything has wind, human, and animal power. For example, you see the boat being pulled by horses. The Barton is an arch form, a pre-Industrial Revolution stone bridge with Roman form. In contrast with the Barton Aqueduct, the Pont Casilta Aqueduct is iron, and it's much higher. The columns are also hollow, so Telford is beginning to think about minimum materials, efficiency. Not only are the columns higher, but they're much more slender than those of Barton. And if you see on the top this image, these little tiny dots, those are people, just to give you a sense of scale. This bridge is very tall and very large. If we take a closer look at the structure, we see exceptionally slender arches, and this is a different aesthetic from the stone arches of the past. In the front there's a weathering plate, but the actual structure are the verticals and the arches. In 1799, there's a huge competition for a London bridge across the Thames River, and Telford proposes a single 600-foot span to allow shipping to pass beneath unobstructed. This is way beyond what had been done before in any material. Nothing of the span had been done, not even close. Telford's design impressed the committee the most, so the competition committee consulted many iron users, including university professors, to see if such a design was even feasible. Although the consensus was that the design could be built, Parliament never acted upon it, and it was never built. I have a question for you. How do you critique bridges? How do you measure the success or failure of a bridge?